Hello. Purpose of today's video, this is just going to be really brief. Talk about some issues related to the last quiz that we took on using the zero product rule. In this video I omit 1 and 2 because most people got the basics down. It's when things started to get a little different that people started to mess up. So the premise behind every single one of these questions is, how does the zero product rule help us to solve certain kinds of quadratic equations? So they need to actually create a zero product. That is to say, I need one number times another number equals 0. And here I see a number plus another number, and it does not equal 0, so I have to do something to my equation in order to make a zero product. Before I do, I'm going to make the observation that the left-hand side of the equation is a simulation of y equals 3x squared. If I take all the x's and plot out all the different numbers that the y's or the left-hand side will equal, I'll get this little parabola right here. And then on the left or the right-hand side, I see a line with a high y-intercept and a very steep slope. But just to get a facsimile again, this is going to be 12 right here. There's going to be some intersection in the positive realm, which will be larger, and there's going to be a smaller negative intersection. Even with this crappy sketch, I can get that much information. Now, to create a zero product, I need to do two things. First, I need to get everything over to one side of the equation. That gives me the zero part. And then I need to factor this so I can make a product, zero and a product. So I follow through the factoring algorithm, which is covered in an earlier video. And when I factor, I can now apply the zero product rule because I have the product of two numbers equaling 0. Each of these separately could equal 0. So I get my two solutions and I check. So for this one, it was really a matter of two things. Number one, some people struggled with coming up with the appropriate factors. Others didn't get the whole zero product rule thing, which is a major malfunction. Now over here, the same thing is true. Oops, I went a little fast there. The same thing is true. First of all, in the graph, I have y equals 3x squared, which is just a parabola centered at the origin, and I have y equals 8x, which is a line with a 0 y-intercept. So I already know that 0, 0 is going to be one of my solutions, which should be common sense. Put in 0 here and 0 there, you have a true statement. The other solution should be another positive number. I could tell that from looking at this graph. Now, to find that positive number, I need to create a zero product situation. Now, here I have the 0 part by subtracting 8x from both sides, and now all I have to do is create a product. I could do so by factoring the expression on the left. Now, before you start diving into Xbox and Magic Diamond algorithms and all that, why don't you just look at this and say, are there any common factors? And the answer is yes, the common factor of x. And now I have a product. X times this number, x minus 8, 3x minus 8 is equal to 0. Therefore, I can now apply the zero product rule and get my two solutions. For the sake of time, I put this into Desmos, even though this was a quiz. I just wanted to show you that I verify my results just as I expect you to. Now, here's the problem. We have a product on the left-hand side, but we do not have a 0 on the right-hand side. We need a zero product. Both conditions must be in place. We must have two numbers multiplied together, and the result must be 0. So I say the first one, right-hand side must be 0, so I'm just going to add 4 to both sides. Problem is, this is a sum of a product and the number 4 equals 0. So there's no zero sum rule, there's only a zero product rule. So I need to take everything on the left-hand side and make it as a product of two different things. In order to do so, I'm going to FOIL these two binomials, collect like terms, and end up with the expression negative x squared minus 6 plus x. Now that's equal to 0, and because we have equal to 0, we can do both sides, whatever we want to both sides, and maintain the truth. So I'm going to multiply this by negative 1, which takes the opposite of everything on this side, and I'm going to multiply 0 by negative 1 as well, and I still have the same truth, just a nicer equation. Now I can use my shortcut for factoring and find the solutions. So what made this tricky for some is they don't understand how to create a situation in which a zero product rule can be used. I checked my answers and it works, and some people actually did adequately draw a sketch for that as well, but most people didn't have a clue. So, second to last question. This was a real shocker. I was surprised how many people got this wrong in one way or another. Because there's two different ways you could do this. The first is to use the zero product rule, which in this case I prefer because I'd like you to demonstrate what you learned. So zero product rule says I need a 0, and now I need a product. So I have to take 16x squared minus 49 and factor. Now, if you tried using Magic Pyramid or Xbox on this thing, you would have had some very, very large numbers, 16 times 49, that you would have been responsible for factoring. Instead, if you recognize that this is a perfect square and so is that, and they're being subtracted, this is a difference of square situation, and the factors are automatic, or should be anyway, in which case we could solve each and get two solutions, positive or negative 7/4. Consistent with my graph, a parabola centered around the origin and a horizontal line, those should actually cross and symmetrically. That is to say, from 0, we should be above or below by the same amount. Go up 1 3/4 or go down 1 3/4, vice versa. Now, the other way you could have solved this, and I would have been fine if you actually did this right, but you can, instead of using zero product rule, just apply inverses. I inverse multiply 16, which is divide 16. Then I inverse square, which is square root. And then I inverse absolute value, which is considered two situations. And x could be positive or negative 7/4, which is the same result I got over here. The problem with this method is, number one, it does not demonstrate appreciation of the zero product rule. And number two, if you don't remember to put the absolute value in, you will only get one of two possible solutions. And without belaboring this point, to get this video wrapped up, I just want to again say zero product rule, zero product rule, zero product rule. Here I don't have a 0 on either side, so I need to make it so I can get a 0 on either side. Before I do that, I'll make a quick sketch so I know what I'm anticipating, two positive solutions, and then I FOIL the left-hand side. After you FOIL the left-hand side, now if you square it and just make it x squared plus 1, that's a math crime, but if you FOIL it, you're good. Now I'm going to subtract x squared from 2x squared and get x. I'm going to subtract 2x from negative 5x, get negative 7x. Subtract 1 from 11 and get 10. This is nicely factorable. I can apply my shortcut. I get my two solutions. It's consistent with my graph, and check it in the final. So thanks for watching.